representing SMK Tun Habab from Politik District.
Today we are going to explain to you more about acid and base.
So, do you guys know what is acid and what is base?
Yes.
Okay, but to make it more clear, I would like to call Sharvina for the detailed explanation.
Okay, now first we are going to see what is an acid. Basically, in general, acid is a substance which ionizes in water to produce hydrogen ions. As you can see, this is the equation where hydrochloric acid ionizes in water because acid always needs water to show its characteristic, produce hydrogen ions and chloride ions. So for acid, we have strong acids and weak acids. Strong acids are the acid that has complete ionization in water to produce a high concentration of hydrogen, whereas weak acid ionizes partially to produce low concentration of hydrogen. And then we have monoprotic acid and diprotic acid. The difference between monoprotic acid and a diprotic acid is that monoprotic acid only produces 1 mole of hydrogen in an acid, whereas the diprotic acid produces more than 1 mole of hydrogen in an acid.
Okay, hold on. So, let me ask them the question. So, any of you here know an example of monoprotic acid?
Acid nitric.
Correct, nitric acid. So, other than that, diprotic acid? Sulfuric acid. Yes, good job guys.
And then for acids, we have mineral acids and organic acids. These are the examples of the mineral acids, whereas carbonic acids, nitric acid and sulfuric acid, and organic acids are methanoic acid and ethanoic acid. Usually the pH for an acid is below than 7, which means 1 to 6. And acids are usually used in industrial process or agriculture, such as sulfuric acid we use in electrolytes in car batteries to make paints and fertilizers. Nitric acids are used to make dyes and plastics, and ethanoic acid or ethanoic acid are used to formulate latex.
So now, I am going to explain about base and alkene. So let me explain. Definition of a base: a substance which ionizes in water to produce hydroxide ion. So we have two types of base. For example, we have ionic bases, which are metal oxide and metal hydroxide, and we have covalent bases, which are ammonia solution. So what is an alkene? Alkene is a base that is soluble in water and ionizes to produce hydroxide ions. And in alkene, we have two types of alkene. We have strong alkene and weak alkene. Strong alkene completely ionizes in water to produce high concentration of hydroxide ions, whereas weak alkene partially ionizes in water to produce low concentration of hydroxide ions. Other than that, base and alkene are also used as ammonium hydroxide for detergent and soap, and we have ammonia gas for nylon and cleaning agent, and we have aluminum oxide to make antacids. So other than that, the pH of an alkene or a base is 7 and above, which is 8, 9, 10, 11, 12, 13 and 14. 8, 9, 10 and 11 are weak alkene, whereas 12, 13 and 14 are strong alkene.
And same goes for the acid, whereas 1, 2 and 3 are usually classed as a strong acid, 4, 5 and 6 are weak acids. So now for the experiment, here is a simple experiment to show the color differences in acid, alkali and base using phenolphthalein, methyl orange and a universal indicator.
So before this, do you guys can guess what solution is this? Acid? This one? The color look alike, right?
Yes.
So now we are going to test what solution is this, whether acid, alkali or it's neutral. So come.
Okay, now all of these solutions here are clear. We use indicators to indicate whether it is an acid, an alkali or neutral. So either one of here, one row of conical flask here we have used acid, which is hydrochloric acid, and another row we have used alkali, which is sodium hydroxide solution, and for distilled water we represent it as a neutral solution. Now, let's take this phenolphthalein and immerse it into a solution. Right, as you can see here, the color differences between this and this remains the same, and this right here turned into pink. This is because this shows that the solution right here is an alkali, because alkali usually change its color from colorless to pink in phenolphthalein solution. But now, how do you find the difference between acid and a neutral solution? That is why we use litmus paper. To test an acid, we use a blue litmus paper where it changes into red, whereas the neutral solution, the blue litmus paper doesn't have an effect on it. Now, moving on to the methyl orange. As you can see, there are color differences between these three of the solution. The acid solution in methyl orange would change into red. A low concentration of the acid will actually change the color of the solution into brick red, whereas the alkali solution and the neutral solution here remains the same color. How do you know whether it's an acid or an alkali? Same. You use a litmus paper, a red litmus paper, so that it changes into blue in the solution. But then you have to remember one thing here, which is the more you add the methyl orange in the solution, the color gets darker, but it stops at one point. So the more methyl orange you add in an acid, it becomes blood red. The more you add in an alkali, it becomes orange, and the more you add in neutral, it becomes yellow. Now for the final test, we are going to use universal indicator. Right, so an universal indicator is the most easiest way to find which is an acid, an alkali and neutral. In a universal indicator, acids usually change its color to red, alkali usually changes into blue, and neutral usually changes into pale green. This is why universal indicators are used in labs to show the beginners for chemistry to identify the difference between the acid, alkali and base. But this is not used in experiment because the colors might confuse the students. That is why phenolphthalein is usually used in experiment, because as it only changes alkali from colorless to pink.
So let me guess. In the titration method, which is a neutralization process, we use acid at the top and alkali at the bottom, which is to easily identify that when we add phenolphthalein into the alkali, it will change the colorless solution into pink. So once we start the titration process, it will turn to colorless back, which shows it is neutralized, is it?
Yes. But you have to remember that in a neutralization process, you have to be very careful while opening your burette, because the more acid you add in the beaker, the more acidic the solution gets, because the concentration of acid in the beaker will get higher than the alkali.
Okay, I understand. Do you guys understand now?
Yes.
Alright, so now we guys have a simple activity which you guys can try it at home, and you guys can play it with your siblings at home. Can we move on to the activity right now? Alright. So for this activity, we need bicarbonate solution, and we need fruit juice, and if it's possible, try to take any juice that contain color, so that your result on this activity will be more accurate and the result is more clear. So now, can you guys see anything?
No.
Do you guys want to see a magic right now?
Yes.
You are going to soak this sponge into the fruit juice, and you are going to scrub it out on the paper. people, here you go with the results. Can you help me to count in a count of 3, 2, 1? Don't stop. 3, 2, 1. This is the results.
Anna, do you have an explanation of what just happened?
Alright, sure. So basically, this bicarbonate solution indicates alkali. And this fruit juice, which we use is star fruit juice, is acid solution. Dragon fruit juice is the acid solution. So when alkali combined with acid, it is neutralized. So the color is pop out.
You can use different types of acids and different types of alkali, and the color changes actually depends on what acid and what alkali you use. Because if you use baking powder instead of sodium bicarbonate, you can actually see that the words pop out in
Yellow color.
So I think that is all for the experiment on what is an acid.
Acid and what is alkali. So